kindly mute your microphone. Okay. Thank you, Theophilus. And then the second benefit is networking opportunities. So since I joined SP, I had a chance to meet so many people. And then that was just last month. I was an honor to receive the SP Ghana president, Ghana section president, to join us on our campus for a summit that we organized here at the University of Energy and Natural Resources. So if it wasn't SP, how possible could it be for us to have him join us for our summit? And then that is a practical situation about how SP advances networking. And then with access to training and certification, that is the professional development I'm just talking about. So today's session is part of professional development, as in having this kind of benefits. It's worth it because it's free as well. And then you won't get it anywhere else apart from SP. And then recognition and awards, that's recognizing the best in the industry. I'm sorry about the inconvenience because it was an unfortunate thing. So talking of the benefits, also on the last one, recognition and awards, that is, SP gives us the opportunity to receive our awards, and then you get recognized in the oil and gas sector. So wherever you go, you get known by people that you've never had a chance to even meet in person. Because of SP, SP is a global network that I encourage everyone to join and then actively involve themselves, since it's going to enhance their perspective and their career pursuits. So without wasting much time, let me communicate to our speaker if it's ready for him to join us and start today's session. So let me check the chat box. Let me check the chat box. For today's session, let me repeat the protocols again. So as soon as you join us, kindly mute yourself. And then if you want to ask a question or raise a concern, kindly use the raise hand icon to show up. And then when you have any contribution, kindly wait for a while. Once you're done with our presentation, we'll allow you to add your contribution. So comment section, in the chat box, we have Frank from UMAD student chapter. We also have Abdullah from SP student chapter. Abdullah, I hope you recognize me. And it's a pleasure to see you join us today. So as far as SP is concerned, do you have any questions about the introduction to SP? Does anyone has a question about SP? Since it seems there is no question. So Justice, I actually wanted to meet you background before you joined us, but please, are you ready for us, or we should engage the guests before time?
Well, you can go ahead. If there is nothing else, you can go ahead.
Okay. Hello, Rama. Kindly mute your microphone, okay? There is a background noise which is interfering with our meeting. Kindly take note of this. Rama, mute your microphone. Let me leave it in the message. And then Abdullah asked the question that is it for petroleum engineering students only? Abdullah, did you mean SP is for petroleum engineering students only or this training section? Can you clarify before your question gets answered? Okay, Abdullah. So SP is for everyone. Everyone has a chance to join SP and then contribute to the oil and gas sector. But looking at the scope of the oil and gas industry, it's a very wide industry. And basically, we have mechanical engineers, electrical engineers, petroleum engineers. And then aside the engineering aspect, we also have the management sector. Or we have, sorry. Hello, Rama, kindly mute your microphone. Let me continue with Abdullah. So SP is for everyone. It's not only restricted to petroleum engineers. As far as you want to work in the oil and gas sector, you can.
Hello, guys. Can you hear me?
Yeah, Sebon, we can hear you.
Okay, thank you very much. Okay, so you're all welcome once again to the first session of Introduction to 3D Modeling. So we have our speaker here. He's ready to impact on us the knowledge of 3D modeling in oil and gas. So he goes by the name Justice. Okay, so Mr. Justice, over to you.
All right, thank you very much, Dr. Pon. And everybody is warmly welcome. And I hope my voice is good enough for you to hear me throughout. Can you confirm that for me, please?
It's clear on my end, but I don't know the others.
It's clear.
All right, thank you very much. So, as the introduction went, my name is, please permit me to bring up. Yeah, all right. So, my name is Justice Alkotian. I am a graduate from the Kwame Nkrumah University of Science and Technology. And I completed school way back in 2022. I'm currently aspiring for a career in the oil and gas industry, intending to specialize in thermal and carbon capture utilization and storage, CCUS. It's a pleasure to be here, and I hope that I'll be able to do my best to whet your appetite for 3D modeling, and hopefully, if you take it a step further, you should be able to add it to your skill tool set. So thank you guys for coming around and spending allotting this time to stop by. And without much ado, let's kindly get started. So the track is going to be in possibly 4 stages, depending on how it goes along the way. In the first week, which is today and tomorrow, we are going to be looking at 3D modeling in the oil and gas industry, where we would take a brief overview of its applications across other industries, and we will narrow it down into the oil and gas industry. And then going the next time, we're going to take an introduction to 3D modeling, the concepts. And then hopefully next we will start, we will be introduced to 3D modeling, the practice of 3D modeling, where we will start learning how to use a 3D modeling software called Autodesk Fusion 360. And then based on the beginner skills we have adopted upon that, from that week, we are going to start a project where we are going to design, please permit me to bring this one up to, where we are going to design a ball valve that looks something like this, where we are going to design a ball valve that looks like this. And hopefully by the time you are done, those who are going to be interested in taking up the skill and developing it further are going to have a very good background to be able to continue upgrading their skill. All right, so please, do you see my presentation again?
Yes, please, Justice.
Thank you. All right, so all right, so today we are going to look at 3D modeling in the oil and gas industry. And in today's presentation, we will look at what 3D modeling is and the advantages of it, and how it is being implemented in the oil and gas industry, and some career opportunities that are booming. And then we will take a look at some 3D modeling software, and then also the future. What's the future holding for a typical 3D designer, and how can one prepare themselves to embrace that future? So 3D modeling is simply the process of using computer software to create a digital version of a physical body. So instead of drawing on a piece of paper, when you compare it to a drawing on a piece of paper, a drawing doesn't have depth. But a 3D modeling is like a drawing that has depth to it. So it feels and looks like an actual body, but it is in a digital environment. And it was created in the 1960s by the creator of Sketchpad called Ivan Sutherland. One of the key benefits of 3D modeling is that it is more realistic, and it contains a lot of visual information. And it contains a lot of visual information. So, and also it has come to replace the conventional and the manual paper technical drawings. And I know during your early years at the university, you may have been taught how to use these tools to draw technical drawings and stuff. But I think as the world is evolving, we should also look into incorporating or possibly replacing those methods of drawing with the software version. And that is why I think this is going to be a very important skill, because I struggle to believe that professionals out there are still having a ruler and a set square and a protractor drawing something. So this is the future, and I know that 3D modeling is going to take a very huge part in it. And then 3D modeling also gives us the ability to design, to simulate, to animate, and also there is something called 3D printing, where what you have designed in a digital space, there are printers that are used to bring it into reality. And then we also have a rendering capacity where you can render it to make it look, to render it to see how it will look like if you put it in a physical environment. It is just picture, right? And we have the visualize. Visualize is how we are able to understand the data we have put into the system with the designs that we have been able to make. And then it also gives us the ability to interact with what we are building. And as we will learn later, and then we also have machining. Most of the equipment that we see around have all been machined. There are machines that are used to cut these equipment out of raw materials, metals. And 3D modeling is a very fundamental part of it, where they design the equipment and then the machine also machines it. Now let's look at why I think 3D modeling is very important. One of the reasons why it is important is that it allows for a very good visualization and then also forecasting. So when you have a 3D device and you are able to perform simulations, and then also based on historical data, we are able to visualize what is going to happen to an asset in the future. And it also very effective for decision making. If I would say that the most important part of decision making is access to information, and not just information, but adequate information and sufficient information. And that is why 3D modeling is very important, because when you have a 3D model of an asset, you have enough information about how it looks. You can even simulate how it would work, and then under different conditions. And once you have all that information, you can make more informed decisions. Another benefit is the provision of team collaboration. Collaboration is very important in today's digitally interconnected world. So it's that 3D modeling softwares now have collaborative features to allow teams that are working on a particular design share information, updates on parts of the designs they are working on. They're able to pass comments without having to go to the office before they do that. And that is very time saving. And that brings us to the next benefit, cost and time saving benefits. I think any company that is seeking to maximize profits wants to minimize cost and time saving. And instead of, as I said earlier, on going to the office to inspect the device and look at your drawing and all of that, it all has been bundled up into a software where you are able to collaborate with the team and send information to them quickly, almost instantaneously. So, and also because undoing errors is very easy in 3D modeling, it is very easy. It saves a lot of time because you don't have to be. Sometimes some errors are so devastating you have to scrape the entire drawing you have made. But with a 3D model, you can reverse back into history and undo the parts where the error is, and then maintain some of your design, which is very time saving. And then we have excellent precision and accuracy. Over here, we are talking about devices, computers that have been programmed with the highest efficiency are going to handle your lines and your sketches and all of that. So as you'd already agreed, computers are more accurate than human beings. And that is a very powerful benefit we get from 3D modeling. Fewer mistakes are made. And even when mistakes are made, they can be called out very easily because there are analytical softwares and features built and troubleshooting features built in software models or software, and then they allow you to identify errors very quickly. Where 3D modeling is applied in the industry today, in various industries today, and I think we are all most probably familiar with this, entertainment and media. We see 3D modeling very, very, very popular there. One area where we also use, and not only movies, but games, right? You see 3D modeling games. We used to have 2D modeling games, 2D games like Mario. But now we are having highly sophisticated and immersive games like Call of Duty and all of that, all made possible by 3D modeling. And then we also have architecture and real estate. Real estate, where you have buildings and constructions. There's some software that you can use to model your structure and see how it will look in the actual environment. And that will help you make some informed decisions about how to go about constructing the actual building. And then it is also useful in advertisements when you are building some apartment or structure, but you want to give your potential customers a preview of what they should expect. 3D models are a very good way to go about this, where you have a futuristic image of your building or of your real estate assets, and then you can advertise it to the people. And then we also have product design. Product design comes in when we are looking at how to designing various parts of machines and equipment. One very good way to plan your design before you execute it is to use 3D models, where you design how you want your device to look and to function, and then to subject it to various tests and simulations to see how it will behave under different conditions, and then to be able to make more informed and effective decisions about how to execute your design. And then we have aerospace and automotive, we have construction, and then we also have healthcare. 3D modeling or designs have taken a very profound, made a very profound impact in health. Now, with the aid of advanced scanners, we are able to scan for internal organs of people, and then we can see parts that are defective without having to cut it open, and that saves a lot of time and save a lot of lives as well. And then we have the very entertaining industry, the VR and the AR, where we have virtual reality and augmented reality. That is what Relo Interactive does. And the goal of virtual reality and augmented reality is to give you a feel of how we can interact with the products before we even see it in real life. And it can also be used in training simulations and educative materials. Then we have finally engineering. In the oil and gas industry, one of the uses of 3D modeling is modeling subsurface assets using geophysical and petrophysical data. We are able to model how the reservoir is behaving at different conditions. We are able to perform simulations and have a three-dimensional look around it to see how it will behave before we subject the actual physical assets to these conditions. Now, let's look at applications of 3D modeling in the oil and gas industry. So geological modeling, we have geological modeling and reservoir simulation for exploration and production. And I'm sure that if you are a petroleum engineering student, you will have been already acquainted with it. But if you are not, what we are really saying here is that before we go in for oil, we have to explore for it. And exploring for it can be very capital intensive. So with the aid of 3D models, we are able to, as I said earlier on, perform different simulations under different conditions to know how the reservoir would behave and to learn more about the reservoir. And once we have developed it and it is producing too, we are able to use the 3D model to visualize how the reservoir will behave under different production and operational conditions to help us decide whether we should go ahead and do it or not. Is it going to help production volume? Is it going to reduce our volume? Is it going to increase the lifespan of the well? Is it going to reduce it? So all of these decisions can be made when we have a very good visual representation of the subsurface assets, which no one can obviously reach. So all that information help us in almost all the phases of oil and gas operations. And then we have facility design and optimization. This is when we are looking at when we want to design pipelines and plants and pumps, and you want to see how, especially the flow area and the separation parts of the rig and the purification and all of that. It all comprises a very wild interconnection of pipes and tanks and plants and pumps and many things. So one of the key uses of 3D modeling here is the ability to design the deck and the area before we actually put it into practice. So we are able to simulate how much long the pipe should be, how big the tank should be. And as long as these variations agree with technical requirements, we are able to know how our layout of the floor is going to be before we actually go out there on the rig to implement that. Now, the next application in the 3D modeling in the oil and gas industry is digital twin technology. And I would like to spend a little bit more time on this one because it is the wave of the future. It is a very powerful and a very efficient technology that has gained a lot of grounds, not only in many other industries, but also in the oil and gas industry. when we talk about digital twin, we are basically looking at a 3D virtual version of a physical asset. So why would we need a 3D a virtual version of an asset we already have? Now, the key to the importance of digital twin technology lies in the ability to remotely monitor your asset. So assuming you have you have a rig somewhere offshore, what digital twin enables us to do is that we are able to create a virtual version of the rig. And then we are able to monitor how the equipment on the rig are functioning. There are sensors and detectors attached to those equipment on the rig. And as they function every now and then, they wear out, malfunction and all of that, their operational status. What we are talking about here is that the sensors pick up that data or those data and sends it over to an onshore facility, which has the computational setup in the facilities to host this digital twin. And then every equipment is linked to a digital version of itself. So as the devices are operating offshore, they are also sending information to a virtual version of themselves onshore. Now, whenever there is any changes in how it is operating, as you may already have guessed, the digital versions or the twin versions of them also respond to those changes, telling the personnel about how well the device is doing offshore. So this gives us the ability to, without sending people offshore, that is cost saving and also time saving, because every now and then people are going back and forth. And then also for sustainability reasons, of course. It enables us to monitor our equipment and our assets without directly being with them. And one of the one of the most powerful benefits is that its ability to predict issues. So it also uses data analysis. So the three major pillars of the digital twin technology, we have 3D modeling, that is computer aided design. We have Internet of Things, and then we also have data analytics. So these three arms are working together to provide the personnel onshore information about the equipment offshore. So if they need to make a replacement, they know when it happens immediately, they are able to take a proactive action. And then also, as I was saying earlier on, it uses very robust analytical models to be able to predict how the equipment is going to behave in the future. So if in 2 years' time, a pump is going to malfunction, the digital twin is able to predict it. And then we are able to prepare ourselves to avoid any sudden interruptions in operations. Therefore, we are able to ensure a very constant and a stable operational condition. And then also, we are able to also run simulations. Let's assume that let's assume I put this pump, I flow this volume of liquid or gas, oil or gas or something through it. What if I do it? What if I increase it to this amount? How long is this equipment going to last? Or am I going to be able to use the same pump to flow oil and also to flow gas? Am I going to be able to use this pipe, okay, to be able to flow the same amount of fluid for a particular length of time? We are able to perform different scenarios until we are able to get a very optimal operational condition under which our assets can work, so that we can make a very good decision about our asset. So digital twin is a very powerful tool. Many oil and gas industries are embracing it. And at the center and at the core and at the very fundamental part of it is 3D modeling. Because these virtual versions are actually 3D models that have been designed and have been connected with the physical assets on field. And then we also have product design and manufacture. I think I explained that earlier. Before you design a project or you design a product, you may need to create prototypes. And instead of spending money and time to design a prototype, with the aid of 3D models, we are able to visualize and simulate how the device would work. And then we are able to, for example, there is a project when I was learning this 3D model, there was a project I worked on, as practice, and it involved like you are manufacturing a chair, a regular sofa, a chair, and you need to understand how much weight it can take. So using a particular maybe aluminum bars, okay, you want this sofa to be able to hold maybe like 10 people at a time. Now you need to be able to simulate this in a 3D model environment before you are not going to design, you're not going to actually manufacture a sofa chair anytime you want to understand how it would work under a particular condition. So you design the model, and then you go to the simulation environment, and then you simulate how the aluminum material is going to behave when 10 people sit on it. Maybe 10 people are going to, on average, contribute to a total force of like say 10,000 newtons. Is it going to be able to hold? You can perform all of that simulation, and you can also understand the various areas where the stress is going to be distributed to the most based on the length, the dimensions of the part that holds the sofa in place and all of that. You do all this on a computer without spending a penny on a physical prototype. And with enough data and confidence, you are able to go ahead and model your device based on the most optimal simulation results you got without spending a dime on prototyping. So that is for the product design and manufacture. And then in the oil and gas industry too, we have health and safety training and simulations. And this is very important. That is when technologies like virtual reality and augmented reality come in, because here you want your trainees to have as much realistic experience as possible to in what you are trying to show them, right? So in a virtual reality, you can create different environments where they would enter when they put those things on, and then they enter into that reality. They are able to simulate how they would, because of how immersive and real it is, they are able to have virtual experiences of how real world experience is. It is good to come and tell them what will happen if they don't wear their helmets or they don't wear their safety boots. But it's a whole different thing when you are able to make them have an experience of how it's going to be using virtual reality, because it can be very, very, very real. And then we have product documentation for marketing and educational purposes. So sometimes when companies like Baker Hughes, when they design a product, they would put it in a video where they would show you how the product works and then give you information about how the product works. And they use 3D models for that. 2D designs are good, but again, they are limited, they are not immersive enough. But with 3D models, you are able to have a 360 view of the devices. And it is closer to the real world than 2D devices, 2D designs. So, and also for educational purposes, of course, you can create a 3D animation of how oil is produced to educate people who are interested in knowing about the industry. And I think this can be also very applicable at universities, even in petroleum engineering classes. Next, we are going to look at career opportunities in the industry. We have product. I mean, these career titles are generic, of course, because every company has their own titles they give to their employees and their offices they occupy. So these are just generic. Okay. So you may be a product design expert. It could be a 3D artist. It could also be a 3D animator. But that is not what is important, I think. I think the most important thing is that having the skill of being able to create 3D models can make you applicable in any 3D modeling role. And as oil and gas engineers, if you want to be a 3D, for example, if you want to design a bit or something, a specialized bit for a particular company, because their formation is probably very unique and it requires a very unique approach. I mean, you need to understand how drill bits work. So that brings us to the point I'm making next. That is, sometimes it requires you to be informed in certain areas. As I explained earlier, you are building a drone. You have to have a very good knowledge about aerospace engineering. If you are building, if you are designing a drill bit, you have to be informed as well. So it is not just solely learning how to design, it also involves you being able to understand the various fundamental concepts, the science and the maths and the physics that govern the equipment you're designing. Now we're going to look at 3D modeling software applications. On the right, you have certain softwares that employ 3D modeling, and then how it is applied in the oil and gas industry. For geological and reservoir modeling, we have Petrel by SLB. We have Dual Suit by Baker Hughes. And most of these are internal, but the majority of them are also out there that can be accessed by anyone. But most are also, for example, a Dual Suit like this is for only Baker Hughes. We have the GeoProbe for Halliburton. It is their software. We have Aspen RMS. They have Surfer. And then we have for facility design and optimization. We have Aspen One, Aviva, UDMS. Also, there's Plant 3D. We have Hexagon Smart 3D. And for product design and manufacture, we have SolidWorks, Autodesk Inventor, and Fusion 360, which we are going to be using for our projects in the coming weeks. And then we also have FreeCAD. SolidWorks is actually a very popular software, but I didn't get to use it. But the cool thing about this environment is that no matter how much different they try to be, there is always there are always a lot of similarities. If you're able to use SolidWorks, you should be able to transition into any other software environment. If you are able to use Inventor, you should be able to use Fusion 360 and vice versa. So don't be worried if you don't know which one to choose. Once you're able to choose one that aligns with your learning abilities and your pace, you are free to go. Very soon, if you want to maybe learn Inventor for a job role, maybe some companies actually use a specific software, right? But once you have the concept at your tips, you can work with those software without difficulty. Then we have health and safety training and simulations. Product marketing and documentation. Yep. As I explained earlier, some software like Cinema 4D, the fourth dimension represents time, of course. Then we have Blender. These are very popular. We have 3ds Max, and then we have Maya. The last two are from Autodesk, and they are very powerful as well. 3D Max like this can be used for designing games, and Blender as well for movies, Cinema 4D for movies. And that is when you can use it for health and safety training and all of that. Now, I want us to take a brief look at some of the models I'm talking about, some models that can be generated in 3D model. This you see here is a subsurface asset. And as you can see, you have the length, the height, and the breadth of the reservoir. And those red and blue poles you see there are all um, oil, oil and gas wells. I suppose the red is for um, gas and the blue is for water or something, but water injection. But it is not labeled, so you can't be too sure. But the point is that sometimes 3D models are able to give you spatial visualization of your underground assets, and you are able to make better decisions. And then we also have a facility model where maybe not when you bring your fluids to the onshore from the ground to your rig, it has to pass through a series of pipes and pumps and tanks for purification and all of that. So a 3D facility model looks like this, and then this can be built, and then before you actually put it on the rig. So then we also have product design and modeling. You can design a product, and then before you implement and manufacture it. And then once again, we have digital twin technology. But just not to confuse this image with the reality, the two images you see there, the actual pump and the virtual pump, it doesn't mean that they are always this close. Okay, the virtual version is sitting somewhere on the cloud, onshore on some computers. And then the asset is several kilometers out. And then we have safety training. So in a virtual environment, you can put someone in an environment where they are able to undergo safety exercises. And it will reduce costs a lot, because I'm thinking about how much it will take for you to run safety tests, and also safety trainings can be a lot of money. So with the implementation of 3D models, we are able to show a video of how people can do stuff, take safety precautions, and sometimes put them in the virtual environment. The last example, hopefully, is product documentation. This video is actually from Baker Hughes, and I would like to. Okay, so in just a few minutes. All right. So that was an example of a product documentation by Baker Hughes. The next thing we would, and probably the last thing we would look at, is the outlook, where we would talk about the 3D modeling and its future prospects. And I think that the most revolutionary area of application of 3D modeling is going to be in digital twin technologies, because as sustainability and cost cutting has become very important to many companies, being able to rely on digital technology like this to undertake many operational duties is going to be very, very embraced. So I think digital twin has come a long way back in 2010 when NASA first used it to help bring a spacecraft that had been stuck in space. They were able to build a virtual version of the device, and they were able to use it to bring their crew down again. So, and that was the first time the term was used by NASA. But from there, many industries have picked it up as well, and they are running really fast with this. So I think one of the key areas where this 3D modeling is going to thrive a lot is in digital twin technology, because it is really robust and requires the use of many complex and sophisticated 3D models. So, in as much as oil and gas is going to stick around for a long time, the digital twin technology is going to be very popular very soon, according to the research I have done. So, anyone looking into adding 3D modeling to their skills should also be eyeing this part of the industry, because once it booms, it is going to be very, very, very powerful. But it doesn't also undermine the importance of 3D modeling in other areas of application, like product design and all of that. And I think what I really think is the benefit of this is the fact that you are able to apply it in a vast majority of industries. You know, you are able to apply it in many areas, not in the gas industry. I remember back at school, I was sitting in the library, College of Engineering library, and then a fellow walked up to me and asked me, he saw me, work on the program on my reading, and I said petroleum. And out of surprise, he asked me, what business has a petroleum engineer with 3D modeling? Well, I didn't give him an answer because I didn't think it was a legitimate question. But I mean, if anyone of you is asking the same question, the way I see it is not necessarily that I have a particular field in mind I was applying to when I was learning it. But I think we are in a very competitive world where what you can do is what takes you far in the industry. What you can do is what starts your career, maintains your career, and sustains your career. So the ability to have the resources to add all of these skill sets is very, very important. So apart from seeing it as a skill you need in the industry, I think my advice to all of us as we embark on this journey is to see it as a very valuable asset that they are adding to their skill set for a future opportunity that's going to come. Because the world is getting more digital and digital every day. And once we have the time and the resources, I think the best thing to do is to prepare ourselves for all of these opportunities. So there is a great deal of applications in the industry, but I think in addition to that, we should also embrace it from this standpoint as adding it to our skill set and preparing for what the future holds. So product design, you can be a petroleum engineer working for a company that is in the mechanical engineering space because you can do a 3D you know how to model 3D. You get it. So I think that is all I can say on that, and I hope that it is able to us for what we are going to do tomorrow and in the subsequent weeks. Next week, we are going to look at introduction to 3D modeling, the various concepts, and hopefully that's tomorrow. Hopefully, we will be able to you'll be able to start our project probably next week. But tomorrow, God willing, we are going to start and introduce ourselves to 3D modeling and then see if we can do some practice. And I'll try my best possible to make sure that this journey is going to be a thrilling and a very inspiring one. So I hope that we are all ready and willing to commit the time and the resources to be able to make it to the end. And a few things I am going to recommend for us to do is to create an Autodesk account, register for the Fusion 360 data trial version, and prepare the software for God willing next week. So thank you all so much for coming. Once again, my name is Justice, and I'm really honored to have all of you attend this webinar. And thank you. I'll see you guys tomorrow.
Thank you so much, Mr. Justice. Thank you for your time and an insightful discussion. The prospects of 3D modeling and digital twin technologies are truly fascinating. And I'm excited to be part of this and then explore their potential applications in the future. Okay, so from here, please, do any of us have a question? If you have a question, kindly use the raise hand icon so you can be allowed to speak, and then our speaker will assist us with that.
And by the way, I have posted the links to the things that you might need for our software in the chat section, so you can access it. Please.
Okay, thanks once again, Mr. Justice. Any questions? It seems there is no question. So once again, our speaker has shared the link to get a free trial version of the Autodesk Fusion account. So before our next session, you can kindly use the link to get yourself the software and then prepare for our next session. So on this note, thank you so much everyone for participating, and we will call it a day.
Adolf has
sorry. Yeah, it seems Adolf wants to talk. Hello, Adolf. Please, can we hear you?
Justin, thanks so much for this very detailed introduction to 3D modeling. From how 3D modeling started from future of 3D modeling, I think I've been very impressed with how today has gone. So thank you so much. I have two questions. Hello, can you hear me now? I think Osebons was saying he can't hear me. Hello.
Yes, we can hear you now.
You can hear me now. First of all, I was thanking Justice for the very detailed introduction he has given us today. I've been very impressed with how today has gone so far, from his introduction with how 3D modeling started from to the future of 3D modeling with the digital twin technology being one of its futures. I have two questions. The first one is, with the advent of AI, I would want to understand how this industry will be impacted, and if any, if first of all, the industry will be impacted with the advent of AI, and how can 3D modelers prepare for that future? That's the first question. And out of curiosity, I just want to ask, with the digital twin technology, what is the lag time is between the physical and the virtual assets? And what I mean is, whatever data that is being captured on the physical asset, how many minutes, how many seconds does it take to be recorded on the virtual assets? Is it instant or it takes some time? Those are my two questions. Once again, Justice, thanks so much for the discussion today. It's been wonderful.
Oh, thank you very much, Adolf. And the questions are, and honestly, I think before I even came, I was thinking about this same question, especially the first one you asked about the AI taking over and all of that. I think at this point, whatever we are doing, we always have to look over our shoulder and see if AI is not coming to take it away from us. So I think it's a very legitimate question. And I think the way I see 3D modeling, and funny enough, yesterday when I was going through the software preparing and stuff, there was a section that is like AI assistant where you can generate an image. Okay. But I think for an AI to be able to generate a 3D 3D model, I'm not saying it is impossible, but I think it is going to be something that is going to be a little quite far in the future, because even a person sitting down to design a 3D model requires very robust resources, like really robust resources. And I think AI will also play a role, especially in the technology like the digital twin, because for example, the sensors and all of that, you need some form of intelligence to be able to separate noises from the data and to be able to get clean data. So AI is very important. It is more of like working alongside with us. But I doubt to believe that it is going to be very soon that AI would take a complete dominion over the 3D modeling field, because the computational resources are a lot. Even generating a 2D image is a lot. So comparing that to a 3D model, I think it's going to take the world a while before we get there. So I have not come across any AI application that designs a 3D model, but presently, these are my thoughts. So I think the way I see it, it should not deter anyone from picking up the skill, because as I said earlier on, it doesn't seem to me that it's something that is going to happen very, very soon. It's going to take the world a very long while before we get there. And then also with the lag time between the lag time that it takes for the data to be sent to the, I think I would say it is near instantaneous, right? I might not be able to give a specific time, but it is enough, and it doesn't delay enough for engineers to be able to make, because the goal of the digital twin is to be proactive. So why would you spend money and resources on a device that is not able to provide you information at the right time when you need it, right? So again, I might not be able to give a specific number as to how much time it takes, but according to my search, it is near instantaneous. That it is almost as sending an email to a friend, and it also depends on the connectivity available. Now we have 5G, and that also counts. So I think if we have all of these factors and the best infrastructure in place, network and all of that, it shouldn't be something that would be a problem at all. It might not be very, very instant, like sending a WhatsApp message to friend, but it is also not any slow. Okay, it is also not any slow. So I think the world is advancing, technology is advancing, and I think in the future probably it's going to take a snap of a finger or the blink of an eye. But now it is enough for engineers to make the decisions they have to make, and it is almost instantaneous. I don't know if I was able to answer your question. If there's any follow-up, I would like to hear it, please. Thank you.
Oh no, very much, sir. You've answered everything. Thanks a lot, Justice.
You're
So much. Another question. Please, is there any other question? Okay, so continuing from here, our next session is going to be tomorrow at 3 p.m. And then as the speaker shared the link onto the chat box, you can use the link to register for free trial version of the Autodesk Fusion 360 software before tomorrow. So if you're a student, you can use your student ID or admission letter to acquire a year student's license to access additional features. But if you're not a student, you can register for the free trial version. Please, is there any other, or would someone like to contribute to the discussion? Okay, so on this note, thank you all for joining us today. End the meeting here. Enjoy the rest of your day.